Okay, so today we're going to be looking at different magma batches. And we're going to try to then match those magma batches with the different types of igneous rock. And we have three types of rock. We're going to look at basalt, basalt, depends how you pronounce it, andesite, and rhyolite. So here are our three different magma batches. The first one is this one. It's bottle number 1. If you're on this page, we'll look at the very top. We're going to have somebody with their iPad time this and tell us how fast the marble went from the top to the bottom when I flipped the bottle over. The travel time in seconds. So who would like to time this on their iPad? All right, Maddie, go ahead. The timer. Should I pull that up? Now this is what kind of a liquid?
Water.
Water. It is going to be very runny. It is very runny. Now, we talk about viscosity when we're talking about liquid. Viscosity is how thick or runny a liquid is. This is really, really runny. So the viscosity is low. It's not really thick. It's really runny. So viscosity is low. We're going to go ahead and we're going to have somebody come up here and they're going to tell Maddie start. And they're going to flip it, and they tell Maddie stop when the marble reaches the bottom. And she'll tell us how many seconds it took to get from top to the bottom. Don't forget to say start and stop for her. Okay, Kaylee, come up here. You're going to stand here so everybody can see you. Okay, ready? Maddie, she's going to say start.
Start.
Stop. Oh, she didn't say stop. Try that again. You have to say stop, or the timer keeps going. Try that again.
Stop.
No.
Start, stop.
You said start before.
Yeah, you said start. It's going to look like this. You say start, then you flip, okay?
Start. Stop.
Okay, you took too long. What is going on? Come on. Let me just try to here. Okay, start, stop. 1.35. Can you please do a one? Thank you, Kaylee. 1.35 seconds. And then it's going to ask, what's the relative viscosity? Well, if I have 1.35, I come over here. 1.35 is about here. If I plot the dot right there about 1.35, what viscosity does it tell me that it is, kids? Low. So right here, put low for relative viscosity. Bottle.
Thank you.
Put low. Yes, you plot it down here. Okay, eyes
Back.
So now we're going to do bottle number 2. Bottle number 2, look at this liquid here. The viscosity here, before I tell you what you think it is,
Question.
what is this liquid in here? Do you think it is, Alex? What do you think? Oil. Yeah, it's like corn oil, or western oil, corn oil, frying oil. Now, this is not as liquidy as the water, right? This is a super low viscosity. There's not going to be any resistance for the marble to get from one end to the other. This one has about a medium viscosity, so there's going to be some resistance. We're going to take a look. Jonathan, you're going to say start, and then you're going to tell Maddie to stop. Don't forget to say the stop part. Not this because everyone wants to see. So right there you go.
Start. Stop.
3.23.
What was it?
3.23.
3.23. Everyone please write 3.23. And then go ahead. 3.23 would be somewhere in here. Then go up to the graph. And what would the graph tell you the viscosity is?
Medium.
Medium. And not high, because 3.23 is around here. So right here you're going to put medium viscosity. Our last bottle, 3.23. Is this one?
Honey.
Well, it's not honey. It is Murphy one. No, applesauce would be really runny. This is what? I think I heard it. You're the first person in all the years that I've ever done this. No one's ever said that. And you are right. It's Murphy's oil. We've never had somebody actually guess it. So kids don't know because it's a wood cleaner, and some of you don't clean.
I clean up my house.
I take that back.
I was the only one.
All right. Yes. Yeah. Go ahead.
Kyle.
Kyle says stop. And start first and then stop, okay?
Kyle's face right now. You look sad.
Let me see it, so don't cover.
Yeah, Kyle.
Stop.
Stop.
It's still going.
10.30, everyone. 10.30.
It's still
Thank
going.
you. It's okay. 10.30 is fine. 10.30.
There isn't a
Okay. Wow. Well, what do you assume it's going to be then? High. That's going to be high viscosity. It is really thick. We're still videotaping, so don't stop. Now I'm going to show you 3 rocks. The rocks, what do they have to do with this? They have a lot to do with this. And I'm going to ask for your kids, I'm going to ask for you to focus. Thank you. They have a lot to do with this because we're pretending this is magma. And all magma that erupts from volcanoes is not the exact same type of magma. Some of it is high viscosity, really thick. And some of it has low viscosity, really runny, and in between as well. So the ones with high viscosity are really thick, but the ones with low viscosity are like this bottle, number 1, really runny. How about you think of a stick of butter? You put it on a frying pan. The phone rings. You go to another room. You forget the butter on the frying pan. You're there talking for 30 minutes. It was on high. Suddenly the alarm goes off, smoke detectors, and you run back in and you're like, oh my gosh, the butter has been on that frying pan on high heat. It's really runny now. It was thick right before. It was solid. And now it's runny, but the color of the butter would be what color? Black. It's burnt. It's just burnt. It's black. It is super runny, super dark. Will you be able to touch the butter?
No.
Oh, you're gonna get burned. The high temperature made it super liquidy, and it keeps burning because it's trying to cool down. Right as you turn it off, you look at it and you're like, oh my gosh, it's super black. It's burnt because it kept burning, right? So because it kept burning, the darkness of the butter is because it's burnt, right? And that is the same kind of concept with the magma. If the magma is really runny, it must be super high temperature. And in order for once it finally cools down, solidifies, hardens, the actual rock will look black. Let's take a look at that. Keep videotaping.
At least you don't need to.
Just look at that. So here we go. Take a look here. If you guys, can you please get the light for me? Hello. The light. If you take a look at this, when you look at the photomicrograph, here's a sliver of this rock under an intense magnification. And they're looking at to see if this rock, which we don't know what kind of rock it is, if it has a lot of silica. Silica has a hexagonal shape. Do you see hexagonal shapes here?
No.
It does not have, it's like 0 to 9. I just something that might kind of look like it was forming there, and maybe another piece somewhere else, but you really don't see a lot of hexagons here. When the magma is thick, there's a lot of silica. It takes a short time for it to adhere, they all adhere, and then a short time for it to harden. Here, I can tell just by looking at this that this had low viscosity. And it burnt. And so this rock is going to be dark, because the longer it takes for it to cool down, the more it keeps burning. So that rock will look like this, which is basalt. Let me show you. Here it is. That's the color of it. We'll pass this around in a second. This has low silica. I could just tell, I don't even need to know the name of the rock, but I know that because of its igneous rock, that this was a rock that had high temperatures. It was really runny. It took a long time for it to solidify. It's burning, and it took a long time for it to harden, so that by the time it did, the rock kept burning. Burning, and it's a dark rock. That has low silica. I'll pass it around in a second. The next one I'm going to look at is that sample. Do you see any hexagonal shapes that would be silica? that would be andesite. Now, it's not as dark as basalt. It's medium color. There is silica here, which means that the temperature wasn't as high as the basalt. Because this takes a shorter time to adhere and cool down. It is just like bottle number 2. Whoops, that's not bottle number 2. Here's bottle number 2. Yes, we already mentioned that. Thank you. Bottle number 2. Okay, so that means it has a medium amount of silica. So far we've got these 2 rocks, and that's called andesite. We're going to write this down on the bottom here. We'll do the first one. Basalt. Everyone write basalt there? Basalt. Yep. And that one was a dark rock. The silica was low. There was none. Low. The relative viscosity for that? Low. It's really runny. Similar to which bottle? Bottle number 1. The second one, rhyolite. Rhyolite is right. I'm sorry, not rhyolite. Andesite. Thank you. Andesite. 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 It is a medium colored rock. The amount of silica was medium. It wasn't like a ton of silica. Medium. The relative viscosity, medium. And it's similar to bottle number 2. The last one, rhyolite. What do you notice about this color?
It's light.
It's light. R-H-Y-O-L-I-T-E. Rhyolite. Rhyolite is a light-colored rock. I'm about to show you the silica on this. Feast your eyes on the amount of silica that is in a rhyolite rock.
Whoa.
There's so much silica here. The temperatures are not as high as it is with the one that has low silica. This is going to cool down quicker. By no means can you touch the magma. It's so hot, but when you're comparing magma batches, obviously. So here, we're going to put that the silica content is high for rhyolite. That the relative viscosity is going to be thick. So it's what? High. And that it's similar to bottle number 3. If I were to just show you a rock, an igneous rock, and you looked at it, I didn't even tell you what rock this is. I'm not trying to tell you what rock it is, because we'll be looking at rocks in the next unit. But just by looking at this igneous rock, what do you think the content of silica is here? Is it high or is it low? Low. The temperature must be what? High. It's burning. Right. And the relative viscosity would be what? Low. It's runny. If you look at this rock, this igneous rock here, what color is it?
Light.
Okay, so maybe medium because you see it's speckled. So not as light as this. You see this is super light. Right?
Yes.
Comparing this. So what's the silica content on this one?
Medium.
What would be the relative viscosity on that one?
Medium.
Similar to which bottle?
2.
Okay, good. All right, go ahead. And that is for this. So, 5 for science. We'll post that up on Google Classroom.